Assalamualaikum and hi, we are from group number 9. So in this lab 4, which is the lab control, we have consist 4 experiment and we have chosen the experiment number 4, which is the liquid level and flow system as our group presentation. So before we start, let me introduce our group members, which is number 1 is AHMAD SYAHADAH, second one AHMAD SYAHIDI, and myself Muhammad Amir Aiman, and the last one is HANIS BINTI HUSIN. So in the introduction, student will know in liquid level and flow system, proportional control is useful technique for sustaining desired level of flow rates. The control valve or pump speed is regulated. The flow rate is increased by opening the valve or speeding up the pump if the detect flow rate is less than the set point. However, if the detect flow rate is higher than the set point, a lower control signal closes the valve or slows down the pump to lower the flow rate. In the objective, we have found 4 main objectives that need to be highlighted in running this experiment, which is number 1 is to explain how the proportional control algorithm works. Second one is to using Laplace transform and describe the system. Third one is define the offset. And the last one is utilizing the proportional controller and run the system.
Hello, my name is Ahmad Syahidi bin ROSLI. My metric number is DD220080. I will present for equipments. This is the equipment that related to this experiment. First, PC computer with process motion software. Second, process line panel for level control.
In this experiment, there are 3 tasks that involve in running the experiment, which is the task 2, setting up, task 3, using proportional control, and the last task is task 4, varying the KC values. Task 2, first, computer turned on. Second, the process motion software runner. And third one is the pressure line panel active, making sure that the panel is connected to a COM port on your computer and that the communication key is turned to PC. For running the experiment, make sure the valve A is closed and valve B is open, and follow the PID controller as you can see here. And then this is the result in the setting up. Task 3, using proportional control, make sure the value of KC is equal to 10 and then find the value of reference value by using the formula. Reference value equal to initial reference multiple percentage of stage and plus initial reference to find the value of each percentage of step. And then calculate all the value of reference value and then start the experiment task 2 by using the value of 135.2 to find the value of error, control output and total response time. Let's use the same step by using the difference of percentage of step, which is 40%, 50%, negative 30%, negative 30%, the last one negative 40% to find the value of E, M and the total response time. Sure, measure all the value of error, control output and the total response in the table given. Data collected in the computer for the finding experiment in the world. Task 4, vary the KC value. Of KC equal to 100, perform the step input increase the set point 30%, which is 135.2. First condition of KC is equal to 100, make sure the valve A is open and valve B is closed. And then click the run at the software to measure the value of error, control output and the total response time. Is the result measured in the condition only valve A is open. By using the same value of KC, make sure turn on the valve A and valve B before running the experiment in the second condition. So this is the result in the second condition when the valve A and valve B is open. After that, change the value of KC is equal to 1 and measure the value of error and control output and the total response time. For the last step in the task 4, we need to change the value of KC is equal to 10 and measure the value of error, control output and total response time as the final finding result for this experiment. Last but not least, this is the result when the value of KC is equal to 10 by using the same condition of valve A and valve B were open. Last but not least, key in all the data in the Word software as the final finding for this experiment. Thank you. That's all from us.
Hello and hi, my name is HANIS I would like to present about result of this experiment. So after adjusting set point 120, KC5, T1, 100,000, TD0, MO0 and the PC, we get the result which is error, control output and total response time. Next, the value, error or reference value of 10% found on the formula given. Next, this result for task 3, which is using proportional control, that is conversion KC to 10. Next column, value 456 written follower of the given percentage. Next column 7 is written is the value using the already formula given. Next, This is result 4.3.1 for KC100 on the column 3, 30% divide into, that's its valve A only open and valve A and B open. Next, 4.3.2 result for KC1 for valve A and B open. And the last one is result 4.3.3 for KC100 for valve A and B open. Next, observation of this experiment. First, we must ensure that the water level is kept to a minimum throughout the experiment. Next, before getting the data, we have to make sure that the system is in steady state, which is need to wait around 80 seconds. This is important to know whether there is an offset. Next, we observe from this experiment that the system will keep the water level in the tank by making use of the set input. A sensor to acknowledge the system is also present. If the tank water level start to drop, the pump will turn on and fill the tank to the proper level.
For the calculation, as we can see at the result, for the column 1, column 3, column 4, column 5 and column 6, the data we can get straight from the table and the data show in a monitor, except for column 2 and column 7, which is we need to calculate column 2 and column 7. Column 2 is we want to calculate about the reference value after step input, and for column 7, which is we want to calculate error or reference value, which equation for column 2, initial reference value multiply for percentage of stage plus initial value, and for column 7 we calculate which equation error divide by reference value multiply for 100%. So we calculate from percentage step by step for from 0% until 50% and negative 20% until negative 40%. So we can get the data for reference value and error reference value as shown in the table of the result. For the discussion, we discuss many question about this experiment. One of that is what is the cost of the offset. So this is the difficulty of in determining that the system steady state to inability to correctly establish the steady state condition is the root cause of this offset. So dua this level sensor in capacity to measure itself. So there will be inaccuracy because the difference between the output of the system as a whole and the reference output will be sustainable difference. So for the discussion 2, we discuss about describe the general system response, the response time and the percentage of offset. KC is 1. So in this task, the value of KC is set to 1, while the both of valve A and valve B were open. So the system shown that there is no response time to reach the steady state, even though the value of the error is high, which is 71. So this system cannot achieve the steady state because the value of case is very small to get the system rate read. So the pump cannot work functionally and cause the output value is difficult to control by the pump.
As conclusion, based on the analysis of the proportional control system, it is possible to draw the conclusion that when a first-order system is controlled by a proportional control algorithm, the entire system behaves similarly. Additionally, the system gain is never greater than 1. The system will therefore always show an offset error for a step input when the actual output is marginally lower than the reference value. The system gain will improve, the offset error will decrease as KC is increased. Otherwise, if KC is increased, the system's time constant and response time will be slowed down. I think that's all from us. Thank you.